an AWS User Group founder, and it's also serverless focused, and it's based in Bangalore. He has over 6,000 members across both of his groups, which is very insane. That's an insane number. His expertise over and beyond serverless also expand to Lambda, S3, and he will be sharing some of this knowledge with us today. So we will be recording. If I'm not mistaken, Collins hopefully has started the recording by now for our members who won't be able to join because of the holiday. And today's topic, as we can already see in Srushith's slides, is serverless, your gateway to the cloud. And basically today we're going to be talking about how autoscaling, high tolerance, and high availability and pay-as-you-go out of the box is brought to you by serverless. So without further ado, the floor is yours, Srushith.
Yeah, thank you, Hilda. Once again, a warm welcome to everybody who's joining us today for the session. So it is about serverless, your gateway to the cloud. So a little bit about myself. Hilda has already given a big introduction. So yes, I'm an AWS Serverless Hero. I work for a startup called KonfHub, which is a 100% serverless startup where we work in the events domain. In some ways related to how meetup.com works, right? So different, but in some ways. So I also run a couple of meetup groups. One is the AWS user group and another one here in India, both of them in India. So a server, that's so 2014, right? I mean, I'm sure a lot of you might have already heard about serverless or probably even tried it out. So do let us know in the chat. Please do communicate what has your experience been with serverless. If you have built anything in production or just played around, we can make this an interactive session as much as possible. I'll share my experiences of building serverless and how we've built our applications in our startup, and some real world examples as well. So this is a more of an introductory session to serverless. So what is serverless? Right? If you go by some basic definition, serverless computing is an execution model where the cloud provider AWS is responsible for executing a piece of code. So essentially, what it is about, we write a piece of code, we upload it to AWS, and AWS takes care of running it as and when required. And we are only charged for the resources that we consume. So on a very high level, in layman terms, if we have to put it, this is what it is, right? So how did we get here? Right. Just like any thing, there is evolution, right? So first it started with physical machines. Then we moved on to virtualization, then cloud, containers, and serverless. So we'll talk a little bit about how we reached here and what are the various things that were taken into consideration, and what are the various advantages at each and every level. So the first and foremost thing that if you can think about is at every single layer or level, there has been abstraction, right? In the physical service, we had to take care, meaning engineers or the team had to take care of everything, all the way from the physical hardware to writing the code and deploying and maintaining and everything. Whereas in virtual machines, there was one layer of abstraction, which is the hardware. So the hardware kind of was abstracted from us, and the cloud provider provided the hardware. We just had to worry about OS runtime and code. Then came in containers, where there was one more layer of abstraction, where runtime and code is what was responsible by us. And then the last one is serverless, where the only thing that we have to worry about is the code. So as developers, as engineers, what is the most important thing? Or rather, what is the one thing that we are paid for, right? So essentially, it is for solving problems, right? It's not even really for excuse me, writing code. We are paid money to solve problems, and we do that by writing code. So our end goal should predominantly be focused about solving problems using code. So that is where serverless comes into picture and says that, that is what you need to be doing. So why don't you just focus on that? So that is the level of abstraction we are at right now. So let me get into a little more detailed about this particular thing of where we are right now and at what was it at different levels. So the first one is the physical machines. So in the world of physical machines, what used to happen, we had to buy servers, we had to manage them, maintain them, and everything. So this required a lot of planning, and not just planning, it was all guesswork, because we wouldn't know how our application would work, right? Imagine you have a small application that you're trying to build, and you're shipping it to production, you're opening it out to the world, and there are people who are going to use it. So we don't know upfront how people are going to react and how people are going to consume our application, right? So it is all about guessing and ensuring that you have enough infrastructure. And what this means is you have to have heavy investments, which is what we call as capex, capital expenditure. So in this case, what happens is that we have to pay upfront a lot of money, invest a lot of money to buy the infrastructure, and make sure we deploy our application on-prem and whatnot, right? So in this particular scenario, what happens is the application lives on-prem for years, because you have basically spent a lot more money to get the infrastructure, right? And there's low innovation factor, and generally deployment happens in months. So the last two points we'll further discuss as we go through the next layers. So the next one came in the virtual machines. As we talked about last time in the previous slide, there was abstraction of the infrastructure. That means we were able to relieve ourselves from the infrastructure problems. Therefore, we got hardware independence. So in the world of physical machines, it was not only about purchasing the virtual machines, but we also had to make sure that it is maintained, right? So we had to make sure that there's 24/7 electricity supply to the server room. There's appropriate and enough cooling mechanisms in place, disaster recovery. There are so many things that had to be considered apart from your application and far away from your code. Whereas with virtual machines, we kind of moved one step away from it and saying that, okay, I'm not going to worry about the infrastructure. I'll let the cloud provider, AWS, take care of it, and I will just focus on things that are more important to me. Therefore, we achieved hardware independence, which resulted in faster provisioning speed. So if we had in the physical machines world, if you had to buy a server, it is not like instant. I can just go to a grocery store and buy it, right? It requires not only planning, it takes time for us to provision the infrastructure as well. But whereas with virtual machines, the amount of time for us to provision new infrastructure has reduced to a few minutes or hours, right? And now instead of spending the money on capital expenditure, now we kind of spend the money on operational expenditure. Of course, in physical machines, it's both capex and opex, whereas in virtual machines, the capex part is kind of gone because the AWS takes care of it. Whereas here, in the case of virtual machines, it is just operational expenses that we have to worry about. We have more scale. As I mentioned, it is much more easier for us to provision more infrastructure. Therefore, as and when the load is coming to your application, you will be able to provision more infrastructure and serve the load as well. So faster speed and agility and reduced maintenance. Of course, we don't have to maintain physically anything. So that is one less thing to be worried about. So the next one is the containerization. Here we achieved platform independence, not just hardware, right? So in the world of containers, as you might have, if you have worked around or played around with it, so you containerize the entire application. So you kind of provide everything that your application requires in the container itself. So you have platform independence, and you also get consistent runtime environment. Along with this, with containers, it becomes easier and faster for deployments, much faster than virtual machines. And because it is containerized, we kind of will be able to utilize and leverage the underlying infrastructure to a much greater extent, resulting in higher resource utilization. The last one is the serverless part. So in where we are right now, right? So with serverless, there are a lot of advantages. A few of them are mentioned here, which is continuous scaling, fault tolerance built in, pay for value, and zero maintenance. Let's talk a little bit about these in detail. So why one should go for serverless? First of all, there are no servers to provision or manage. Of course, I mean, if you folks have attended previous sessions on serverless, you might have heard about this. Serverless does not mean there are no servers, right? It is as good as Wi-Fi, right? So you get wireless internet, but that doesn't mean that there are no wires at all, right? So the same case here as well. So it is just that we as developers or engineers do not have to take care, manage, maintain the servers, but AWS will take care of it. The next one is configuration-less scaling. One of the biggest advantages of serverless is the scalability part. Since we are not taking care or maintaining or managing the infrastructure, and AWS is taking care of it, it becomes serverless gives a lot of flexibility in terms of scalability. Of course, there's a star mark applied here, terms and conditions applied, because like in any application, there are always limits, at the service level. Like, for example, the number of Lambda functions, throttling limits, burst limits, and all those things, right? So you'll have to keep that in mind. But in general, especially for normal use cases, serverless can scale. I will be talking about one real world scenario where serverless has helped us greatly in terms of scale. So the second most important advantage here is the pay-as-you-go model, which is essentially the amount of money we pay for consuming the services on AWS, right? So in this case, what happens is we only pay for the usage and never for being idle. So what does this mean? So generally, when we talk about cost saving, of course, it is because we only pay for how much we consume, right? But where exactly are we saving money? Right, that could be one question, right? So the actual savings in terms of application cost come when nobody is using the application, right? So that is where the idle part comes into picture. Since you're not paying AWS for your application being available on AWS, but rather you're paying AWS for the amount of time or the number of requests that are coming to the application, it becomes a much more lucrative option in terms of the cost factor, especially for startups or products that are getting started, MVPs and stuff like that. The next one is bring your own code. So we don't really have to make too many changes to your own code. You can still lift and shift the code, but of course it will require some changes. Not more so from the code perspective, but more from the architecture, from the thought processes and stuff like that. So to give again, for folks who probably have not known serverless or not have played around, a very simple analogy that I generally give is the case of cars, right? So with the physical machines, it is like like for example, I want to travel from point A to point B. Now, what is the intent? What is the requirement? Is for my travel from point A to point B. Now, how can I do this? There are three ways generally of doing it in our real life, right? One is I can actually buy a car and I can drive it from point A to point B. That is what is analogous synonymous to the physical machines. Now here what happens, I have to buy the car. That means I have to spend upfront for my requirement, right? That is the capital expenditure. Now the second one, does it stop there? No, I still have to pay for the fuel. I have to fuel my car. I have to make sure that the oils or whatever is required for my car are proper. The car is serviced, and I have to kind of pay for a driver if I want to travel from point A to point B. So there is so much of expenditure out there. Right now, the second option of how I can achieve this is essentially if I can rent a car. right? I can just go to someone, any providers, of course. I don't know many in Zimbabwe, but I'm sure there are car rental companies over there. So you just go there, you rent the car. Now what you're doing, you're not really paying money for the car, right? The value for the car itself. Rather, you're going to pay the rental company only for the number of days or hours, or depending on whatever their billing is, right? Now this is what is kind of your virtual machines, right? Where you don't pay for the entire infrastructure, but rather only pay for how much you plan to consume, right? Now when you rent the car, you have to pay to the rental company irrespective of whether you're consuming or whether you're using the car or not. If it's in the garage, or whether I'm using it or not, the rental company doesn't care. All it cares is, I have given my car to you, and you have to pay for it, right? So even when we are not using the car, we end up paying money. So that is what is your virtual machines in the cloud analogy, right? Whereas with serverless, what happens is like your Uber, right? Or any of your taxi or cab service out there, right? So here what happens is, I want to go from point A to point B. Now what will happen is, I book an Uber, and Uber is just going to charge me for the travel, for the trip, right? It is not going to charge me for the car. It's not going to explicitly charge me for the driver, nor the fuel, or anything else, right? Now all of this is of course included in the trip charge or trip price, but for me it is just one cost, and that cost is for my travel from point A to point B. As simple as that. Now if you can observe the cost saving, right, all the way from owning your own car to renting a car versus a cab as a service, is where serverless kind of comes into picture and gives you a lot of pricing advantage, right? So how does working with serverless? Now this session is about how serverless can be your gateway to the cloud, especially for folks who are getting started, or front end developers who want to get started with backend. I feel serverless is probably the best way to get started. The reason being, first of all, the cost factor, right? You don't really have to worry too much about it. If at all you have to spin up an EC2 machine, then you still end up paying a lot of money if you forget to shut it down or whatever, right? Now with serverless, you don't have to really worry about the cost factor. The second is the ease of use. So that is what I'm going to talk about right now. So how is it generally working with serverless, right? So what happens is, everything in the world of serverless is event driven. That means something has to happen that will trigger the Lambda function, and then it can do whatever it has to do, and then it can update another system or update the database and whatnot. All right. So what you generally have is, you have event sources, you have your Lambda functions, and then you have your targets, right? So event sources are what generally we call it as triggers. So there are many triggers available on AWS for the Lambda functions, all the way ranging from API Gateway, S3, SQS, SNS, Event Bridge, whatnot. So there are a very good number of triggers available on AWS. So let's take a simple example. Right? Let's say you build a small application for converting images, right, from let's say JPG to PNG, or you write a service for generating thumbnails for your YouTube videos, right? So what happens is, in your application, someone just uploads an image, and that's an upload to S3. We can configure a Lambda function to be triggered from S3. So whenever a file gets uploaded onto S3, a Lambda function can be called. In the Lambda function, you can have your business logic for generating a thumbnail, or doing compression or conversion, whatever you want to do, whatever your business logic. You can write that in your Lambda function. And once the target image is generated, you can upload it back to another AWS S3 bucket, or you want to update another database, or you want to send an email. It's just up to you, or what your application's need is. Now, if you observe how serverless works, is there's a trigger that comes up, and once the trigger is fired, we have a Lambda function that comes up, does whatever it has to do. That is where your code is. That is what you focus on. And then when it is over, then it calls the target, or returns the response of the API call, or whatever it has to do. It's as simple as that, right? Now, when we are working with serverless, trying to go in a little deeper now, it is very important to understand the life cycle of your Lambda functions, right? So what happens behind the scenes whenever there's a request that comes in? Like, for example, I told you, whenever there's an image that is uploaded to S3, what happens? Or when there's an API call that is connected to your Lambda function, and your UI or your client, your mobile app calls that API, what happens behind the scenes, and what is that magic, right? So this is the life cycle of your Lambda functions. So there are two parts to it. Generally, you might have heard about something called as cold start and warm start, right? So I'll be talking about that right now. So as I told you, serverless is where you don't have any infrastructure, but the code that you uploaded to Lambda should run somewhere, right? So what happens here? How is it run? And what is the entire process for this is what we are going to discuss about right now. So the first one, what happens is there are two parts to it, as I mentioned. One is the cold start and the other one is the warm start. So let's talk about the cold start part, right? So cold start is essentially the amount of time that AWS takes to provision the infrastructure for your code to be run. Okay, so in this part, what happens is there are three things that happens. One is your code is downloaded onto the infrastructure, the execution environment is set up, the runtime is bootstrapped. So all of this is a part of the cold start. And here again, two parts to it. One is the full cold start and the partial cold start. And then we have the warm start, right? So on the left hand side is what is entirely responsible by AWS. We don't have any control over this, and AWS takes care of it completely, right? So what happens? So whenever a request comes in, AWS will provision the infrastructure for us. So in this case, when we say infrastructure, what is it? Is it a container or is it a VM? What it is? It's a micro VM. So excuse me. AWS has an open sourced micro VM called a Firecracker. If you guys are interested, you can take a look at it. So AWS uses this Firecracker to provision the environment, or rather the infrastructure for us as and when the requests come in, right? So now what happens is the request came in. There was an image that was uploaded to S3. Now AWS received the request and it has to trigger the Lambda function. So that is where it will provision the infrastructure. It will download the code, our source code, whichever we have uploaded to AWS and Lambda function, and then it will start running your code. So that is where the right hand side comes into picture, which is in our control or something that we can take care of. So the first one is the partial cold start. So what is this? So this is where the bootstrap the runtime environment. So what happens here is, before we start executing the code, we have to make sure that all the dependencies, all the modules are initialized in our code, right? So that is what happens here, where the code is initialized. And one important thing to consider here is, in the world of serverless, because we are charged for the amount of time it runs, right? We have to make sure that our Lambda functions are quick. They can finish whatever they are intended to do in a very quick manner. So it is important to consider the modules or the dependencies or the packages that you use in your code, and ensure that they are as light as possible, and you are importing only the modules that are actually required for your Lambda execution. Okay, so let's say, for example, you are doing a conversion or a compression, like the example we talked about, right? So try and pick and choose a module. If you're using any third-party modules in Python packages or Node.js modules, make sure that you're picking and choosing something. Sorry?
Hi, sorry, please can we all mute? Sorry about that. I think you can go ahead.
Okay, sure. Yeah. So what I was saying is, it is very important for us to ensure that the modules and packages that we choose are lightweight, so that the cold start will be as quick as possible for us. Now the warm start part, which is actually the amount of time our code executes, this is completely up to us. So if you write a performant code and make sure that it follows all the best practices of the programming language that you choose, then it'll run faster, otherwise it'll run slower, right? So no, this is what happens each component of the life cycle. Now let's take the example, understand. So now whenever the file is uploaded on S3, our Lambda function gets triggered. So what happens is the infrastructure is provided, your code is deployed into the infrastructure, and your code is run. First of all, how much or how are we billed for serverless? I told you it's pay as you go, but what exactly does that mean? Is we are not charged for the amount of time AWS takes to provision the infrastructure as well. We are actually only charged for the right hand side part. So basically the amount of time our code takes to execute, right? So that is one thing. Now the next thing is, as I told you, what is serverless? Serverless means it's infrastructure on demand, right? So I uploaded a file, Lambda function came into picture. Now it finished whatever it had to do, conversion, compression, thumbnail generation, or whatever. It finished what it had to do. Now the Lambda function's execution is over. Now what happens? This is the important thing to understand here. Now what happens is AWS does not kill the infrastructure. Once the Lambda function's execution is over, even after it is over, AWS does not kill the infrastructure, but it keeps the infrastructure alive for some more time. Now, what is that some more time? Nobody knows. It is not documented anywhere, and it will never be documented as well. So I'll tell you why. First of all, it is kept alive. Right. So as you can see, it is infrastructure on demand. That means it takes a few milliseconds for AWS to provision the infrastructure for us. Right. So what AWS does is it once provides an infrastructure, it anticipates that there will be more requests that could come in. Therefore, it can reuse the infrastructure that is already provisioned, and therefore helping us with the performance, because we're going to save a few more milliseconds, right? Where we don't have to wait for the infrastructure to provision, because we are going to use the infrastructure that is already provisioned for us in the previous request, right? So that is what one important thing to remember here. Now, as a part of this process, what we'll have to understand is only this part, the warm start, is what will run every time the request comes in. Now, let's say, for example, there's an infrastructure that is already provided and the subsequent requests are reusing the infrastructure. Then does it mean that, what happens is your code is what is run every single time. Okay. But there is one important thing to remember here. And before that, I think I forgot one point to mention is, in the world of serverless, everything is stateless. So stateless meaning one execution cannot remember what happened in the previous execution, right? Because they are all isolated in nature. Okay, so because it's all infrastructure on demand, right? So we are not really leveraging something that's already there, so that I can store something, reuse it for the next time, and all those things is not really possible with serverless. Having said that, there are a few things that we can leverage to reuse a few things. Okay, so as I've been talking about, once the Lambda function's execution is over, does AWS kill the infrastructure? No, it does not. So that means that it is holding the infrastructure back, right? So what it means is that all the modules that were initialized stays intact. And the second thing is, all the global Okay, looks like I was accidentally muted. Just go back a few seconds. So what I was saying is, the important thing to consider here is, when the infrastructure is reused, there are two things that are reused. One is all the modules and the packages that were initialized as a part of your first very first time infrastructure setup will still stay intact. And the second, the important part is the global variables. Now, all the global variables that you have defined in your Lambda function will be reused. They will not be reinitialized for every execution. So that is very important for you to remember and take leverage of it. Okay. So why you have to remember is if you have something like a counter, right, where you initialize at the beginning counter equal to 0, and in your Lambda function, in the functions, you increment the counter or you manipulate the counter. Now, the first request, let's say it started with 0, and then in the function we incremented it by 1. Now, if the infrastructure is reused, the counter value will be remembered. So it is not going to restart from 0, but it will be 1 and it will increment there. So it's very important to make sure that if you're manipulating the global variables, you make sure you don't have such things as global variables. Now, how we can leverage this is basically for, you're reusing of a few things. The first and foremost is secrets, right? A lot of times we may have to get secrets for your execution. Like, for example, you are storing the API key for a third-party service in your secrets manager or SSM parameter store and stuff like that, right? So all of your executions require the API key. You don't want to add it in your code for security reasons. So you have to go and fetch it from a secrets manager somewhere. So what you can do is, if you have it at the global level, the fetching of the secrets happens only once for that particular infrastructure, and it can be reused. The second advantage, or a second place where we can leverage, is the DB connections, right? So what we can do is we can open the DB connection at the global level so that the connection stays open, and you can reuse the connection for as long as the same infrastructure is available. So this is how you can leverage the global variables part, because as I told you, the global variables part, initialize and all, we are not charged for it. So you can kind of save a few cents over there. So now I have been talking about scalability, right? Being one of the biggest advantages of serverless. So I would like to talk about how building applications using serverless has helped me in real world examples. So this is one particular scenario where we had built a simple quiz application for one of the AWS community days that was happening here in South Asia. So it was a community day, an online version where we had people joining from 4 different countries: India, Sri Lanka, Bangladesh, and Nepal. So we had people joining from 4 countries. So we had registrations, approximately 45,000 people registering for the event, and we were expecting some 25,000-30,000 people joining the event. Okay, so what we said was, because it's an online event, it is important for us to keep the audience engaged, entertained, and stuff like that, right? So we, as I was part of the organizing team, so we said that, we should start the community day with something that can excite, that can engage people. And then we said, okay, let's start with a quiz. Like a fastest fingers first, right? Where we will run a quiz for some 10 questions, and people will join, and whoever tops the leaderboard gets some goodies and stuff like that, right? So we built an application on serverless, the quiz application. It was completely 100% serverless. It used Lambda functions. It used AppSync for GraphQL APIs, and then it used DynamoDB as the database for the entire application. Right. So one thing that I would like you folks to observe here is the quiz, right, was scheduled for 10 a.m. in the morning. Okay. So you can see here, this is basically the number of requests that our application received during the entire day of the event. Okay. So you can see that at 10 o'clock, approximately 10 o'clock, you can see there's a sudden jump. Right. So, and you can see before 9:30, there's almost 0 or just a few, maybe hundreds or even less than that. Right now, suddenly at 10 o'clock, because 10 o'clock was the scheduled start for the quiz, there was a huge jump from, let's say, for example, 5,000. You can see there's an exponential jump in the number of requests coming into your application, right? And the quiz lasted for 10 minutes, right? I hope my screen is still visible, right? Yeah, okay. Yeah. So the um, the quiz lasted for hardly 10 minutes. But as you can see, what happens is that the number of requests jumped significantly. Now, as an engineer, how do you plan for this? Right? You have to make sure that you have enough infrastructure provision to make sure that there's a sudden jump, right? So generally what happens is we we provision the infrastructure beforehand, right? We make sure that the infrastructure is there so that as and when requests coming, the infrastructure is warm and it can serve to hundreds of thousands of people. But in the case of serverless, as I told you, you don't have to do anything. AWS takes care of scaling. That is what exactly happened here. We as developers, all what we did while this thing was happening, all we did was sit back, watch our logs, look into the graphs that our observability tool was showing us, and more importantly, we were praying that nothing breaks, right? Of course, it's 25,000 people concurrently using the application. Not a huge number, but still a significant number for an application where it went from 0 to 25, 30K in a span of few seconds or a minute, right? So what happened is the Lambda functions just beautifully came in, the APIs scaled, the Lambda function scaled, DynamoDB scaled, everybody played the quiz. And once the quiz was over, you can see there's a sudden drop again for the number of requests to the application, right? Now, you can see there are a few spikes here and there during the event day. So these spikes, as you can see here, are during the event we had multiple quizzes. Of course, the morning quiz was the biggest one because we had a huge number of people. And as and when the day progressed, we of course the number of people joining the quiz dropped and everything. Now, what happened is, but you can see that there's a constant up and downs of the number of requests that the application was receiving, right? Now, that is the beauty of serverless, right? As I told you, from a cost perspective, the money that you save it's not about how much you're spending. Rather, it is about how much you're saving, right? Your saving is your earnings, right? So you're saving by not paying AWS for not running your code, right? So that is the saving part. Now, from scalability perspective, why it is such a huge advantage is, see, scaling up is something that a lot of applications, a lot of people have achieved. It is not a rocket science or anything, right? But scaling down is also very important, right? See, I can make sure that beforehand I have so much of infrastructure available that at any given point in time, 30,000 requests can be handled. But you can see here there's a sudden drop. So I have to make sure that I have to kill all of that infrastructure as well, right? Because otherwise I'll end up paying for all of them. So that is where, again, serverless comes into picture and helps you with cost saving and scalability as well. So this is one quick thing that I wanted to show you folks because this is what happens in real world. This happened for one of the community days that we had done. Now, does serverless mean only Lambda functions? Of course not. Serverless is like your jigsaw pieces or your Lego blocks, right? So serverless has so there are multiple services on AWS which are serverless in nature. And in general, how we build serverless applications is by consuming services. Let's say, for example, I want to run code. There is Lambda function. I want to have an API. There is API gateway. I want to store files. There is S3. I want to have login, authentication, authorization. I have Cognito. I want to have a queuing system. There is SQS. I want to have a notification system. There's SNS. So there are so many services, serverless services on AWS available. But generally, people talk about Lambda functions. Of course, Lambda is your hero. It is the centerpiece of everything. But with just Lambda function, you cannot do much because it's not only about running code, right? You have to do a lot of other things surrounding it. So here is on a high level, the list of other serverless services that are available on AWS. So from a compute perspective, you have Lambda, of course, and then you have the Fargate as well. So Fargate is the serverless containers offering. And then from an application integration perspective, you have Event Bridge. So Event Bridge is like you can have event buses where you can have multiple buses, and Event Bridge is again one of the more popular services of late. It gives a lot of flexibility, a lot of things that you can build with, especially one of them being uh, connecting to third-party services and receiving events from third-party partner event bridge buses and stuff like that. Then you have step functions, one of my favorite services. So step functions is a serverless orchestration service where you can build a workflow. As I told you, Lambda functions are stateless by nature, right? But in most of your applications, you need to maintain some state from one point to another point. So that is where step functions come into picture. Then you have SQS, which is your queuing system. Then we have SNS, which is for notifications. Then we have API gateway for building your APIs, and then the last part is AppSync. This is for REST APIs, and this is for your GraphQL API. So AppSync is the one that we had consumed as a part of that application that I just talked about. Uh, so. Uh, so that is with respect to the application integration. With respect to the data store, you have S3 buckets for file storage. DynamoDB is your NoSQL database. Amazon Aurora Serverless. So this is a relational database, but with the serverless model available. So this is something that we use in my startup for KonfHub. All transactional data and everything we store in RDS, which is Aurora Serverless. And then we have one more thing called as RDS proxy. So what is RDS proxy? Very quick bit is essentially if you have okay, let me give you an example, right? So DynamoDB, again, I don't know how many of you folks have used DynamoDB, but it has a learning curve, in some ways, a steep learning curve to understand the data modeling part, right? So, and not every developer, not every engineer, not everybody is comfortable with DynamoDB for certain reasons of modeling and its rigidity in some ways, right? From a querying and analytical capacity perspective, right? So we are all comfortable with SQL. We know how to write SQL queries and stuff like that. So you would have had applications that run on RDS, right? So so what happens is with respect to RDS proxy, you can have your Lambda functions which can scale, right? It can scale to theoretically infinitely, but what happens is you will be your compute can scale. But does that mean that all of your downstream services can scale? Not necessarily, right? Especially in a lot of cases, your database is the bottleneck, right? So what happens is your database cannot really scale. You have connection limitations and all sorts of things, and your application might not be in a situation, nor it might not be suitable for going with DynamoDB, right? So therefore you stick to RDS because it has always been there. Now what you can do is you can put RDS proxy in front of your RDS, so that your Lambda functions can talk to RDS proxy talks to RDS, right? So this way what happens is the connection management and all sorts of things that we kind of have to manage can be taken care by this service on RDS proxy. These are a few serverless services that are available. And generally, when you're building a serverless application, you generally start with AWS Lambda, but you end up eventually consuming a lot of these services, right? So that is where, if you're starting with AWS or backend in general, you can start with Lambda, because as I told you, it is very simple to get started. All you have to do is write a small Python script or a JavaScript or a Node.js piece of code, upload it to AWS, click on the invoke button, and your function can be executed. As simple as that. Therefore, it is very, very easy to get started, right? But having said that, as I told you, compute is an important factor or important part of your infrastructure or your architecture rather, sorry, but it is not all of it, right? You have to have so many supporting services, right? Cognito, as I told you, any application generally requires login, right? So Cognito comes into picture there, and you would require SQS, you will require SES. So SES is another service for sending emails. So hopefully we will have more future sessions in the future where I can cover a few of these services. So a few use cases before I wrap up the session. I think okay. I am slightly probably behind time. So a few of the most common use cases are web applications, chatbots. Chatbots being a very good use case, because in chat in any chat application, it is basically you're listening to events, right? Someone is typing a message, and that only then that message has to go to the other recipient, right? And when that side of the person replies, it should come here. So it's all event driven, right? Data processing, autonomous IT, and backend as a service. So excuse me. So generally, you would have seen people building APIs, web applications with serverless. So I would like to end my session with this funny comic strip. So what comes after serverless, right? Codeless, deployless, CPU-less. I mean, codeless. I feel that we are probably there right now with all the AI tools, ChatGPT helping you write code with just with just one line of prompt. So are we reaching there? We probably are there right now, and but whatever said, bugs can never go away, right? So we will have to deal with bugs. We will have to ensure that things work, and we will always be there in the picture as developers, right? So on that funny note, thank you so much for joining me for this session. I'm Srushith Repakula, and if you have any questions, I of course will open for Q&A. We can discuss, and if you want to connect with me, I'm available on LinkedIn, Twitter, and everywhere. Any questions, serverless in specific, I'll be more than happy to help and guide you folks, or anything in AWS you wanna chat with me. I'm always open for the same as well.
Thank you so much, Srushith. Wow, that was that was an amazing session, and you sure know your things. You know serverless like the back of your hand. From our attendees, do we have any questions? I had said you can keep your questions up until the end. So this is now your chance. Okay, Tapio, I see your hand is up. Please unmute and ask. So if you have any questions in the meantime, just raise your hand and then we'll get to you. Hi, Tapua. If you were intending to unmute, you did not. You can go ahead and ask your question. Okay, that's fine. Do we have any other questions? Oh, it seems like everyone understood everything that you were saying, Srushith. There must be a superpower. I guess I'll just ask a question on behalf of our audience. So most of us are probably new to the cloud journey, and seeing the wealth of knowledge that you have on serverless, do you have any probably tips or sources that you used to learn that we can also leverage and we can use on our journey in AWS?
Sure. Yeah. So for everybody, again, as I have talked about, serverless is probably your, an easy start to your journey with AWS Cloud. And with respect to the same, one particular page that I generally refer people to, that you can refer to, is the serverlessland.com. I've just shared the website link here in the chat. So this is a website that is maintained by the folks at AWS. So it has a list of patterns, a list of resources, example codes, videos and everything with respect to serverless. So you folks can take a look at this. This is very helpful. It has helped me in a lot of scenarios. So this is one place that I would point you guys to.
All right, thank you. We'll definitely be sharing that link across all our platforms. Vuyisile had asked a question in the chat, and he
Yeah.
was asking if you have any thoughts on future trends in the serverless space.
All right. So future trends, right? So if you have been following the reinvent for the last 2 3 years, you would have observed that there's a lot of emphasis on serverless that is provided. In fact, the last reinvent, not the 2023, 2022 one. In fact, Werner Vogels, the CTO of Amazon, wore a Lambda T-shirt for his keynote presentation. So one thing that could indicate is serverless is the future, and AWS is betting big on the scene. Now, what are the few things that we can look forward in the future with in the serverless space? Is you can see a lot more services that are serverless in nature. In fact, even the last couple of reinvent, you might have observed a few serverless services in the ETL domain that are coming up, that have come up, and the database part, this is something that we've all been bit excited about. So there are a lot of serverless databases out there that are coming up, which are gaining a lot of traction, serverless caching services and stuff like that. So certainly there are a lot of exciting things coming in the future. One thing that I'm looking forward is the database part, apart from the things that we already have.
Thank you. I hope that answers your question, Vuyisile. I see, Tapua, you have your hand up again. Please go ahead with your question.
Hi, yes, I was having trouble with my mic. So I wanted to ask this question. The beauty of serverless is that you can easily scale up and scale down, and that is proportional to the amount of money that you spend on this service. So, as maybe as a solutions architect or as an engineer in general, how do you cover yourself from example DDoS attacks, whereby maybe you're being attacked with a DDoS attack, and you end up paying maybe 500,000 for a simple website that's hosted using Lambda or something like that. How do you mitigate that, technically speaking? So how do you differentiate between real traffic and DDoS attacks so that you don't get billed to an extent that's unbearable for your budget? Thank you.
Absolutely. That's a wonderful question. So this is generally what happens, right? I mean, the beauty is it can scale, but the beast part is it can cost you money, right? Like you exactly pointed out. If you had observed, I think a couple of weeks back, there was one thing that was trending on Twitter, which was about one hobby website of a person who hosted it on Vercel. I hope you guys know what is Vercel. Vercel is a hosting platform for websites and stuff like your Netlify and stuff like that, right? So what happened is his hobby website got so much traction that he did not know, and he got billed so heavily for the same. And Vercel runs on serverless. Behind the scenes, it uses Lambda functions, right? So exactly the case that you talked about, right? So what happens is, yes, this can be a problem, and it is difficult to differentiate between what is actual traffic and what is probably a DDoS attempt, right? So this is where the throttling limits of AWS come into picture, where it is not like it can infinitely scale. Of course, there are limits that are applied in multiple places, right? Like for example, you can only have 1,000 concurrent Lambda executions in one region, right, per second. So there are limits like this, which are soft limits. So these are in some ways protect us. But having said that, it's as an architect, you have to consider all the worst possible case scenarios as well, right? So how do we do it? the first thing that we will do is we will put WAF. So there's something called as Web Application Firewall, if you guys have heard of it. So what we will do is your application will be behind a WAF firewall. So what happens is with WAF, AWS automatically kicks in if it kind of detects something that is fishy, right? And you can also write your own rules saying that, if something happens, or you like, for example, you can block specific IP addresses, you can block requests coming from specific regions and stuff like that. So that is the most basic way that one would try and achieve that. Having said that, this is of course a very difficult problem to solve, because in fact, this happened once in my experience as well. So we had built a platform for learning, which is of course not available right now. So it was a platform that was built from the AWS community here in